Hello, calculus students of mine. In this video, we are going to talk about our 3.6 notes, derivatives of inverse functions. So the first thing we need to do is to review what an inverse function is. So let's talk about some of the things that you would have talked about in your pre-calculus courses. First of all, an inverse function would be a function that undoes another function. So for example, I'm just going to write up here an equation. If you were going to solve the equation 3x equals 6, how would you solve for x? Well, since x is being multiplied by 3, we would want to undo that. So what function undoes multiplication by 3? Well, that would be division by 3. So we would divide both sides by 3. And we would get x equals 2. So you've been using inverse functions for years to solve equations because what do inverse functions do to each other? They undo each other. Okay, so let's go ahead and talk about what we write if we want to indicate the inverse of the function f of x. So if f of x is our function, the notation that we use to indicate the inverse function would be f to the negative 1 of x. All right, now in this context, you've seen this exponent of negative 1 before, and in another context, we might think of about that as 1 over f. But in this context, when we're talking about inverse functions, f to the negative 1 of x means the inverse function of x. Okay, so let's talk about some things that you learned in your pre-calculus classes. If f inverse is the inverse of a function f, then the following statements are true. Well, we've talked about how inverse functions undo each other. So f of f inverse of x would give us x back again. It's kind of like if you took a number, let's talk about a couple of functions that are inverses, like squaring a number and taking the square root of a number. Well, if f is squaring, the function that squares a number, and f inverse is the function that takes the square root of a number, well, if you start with x, take a square root, and then square it, you get x right back again. And if we go the other way around, if you take a number and square it, and then take its square root, you would get right back what you started with. So inverse functions, just like we said already, undo each other. Okay, also, because when we're talking about a function and its inverse, because the domain and range of a function and its inverse switch places, then the point AB on the graph of f corresponds to the point BA on the graph of f inverse. So let's take a look at this picture over here. So here we have a function f. This is our function f of x. Its inverse, f inverse of x, looks like this. Now remember, if you have a function and its inverse, the domain of the function will become the range of the inverse, and the range of the original function will become the domain. In other words, domain and range values just switch places. So that means if I have a point AB on my function f of x, then the point that corresponds to it on the function f inverse of x will be BA. Okay, so x and y's just switch places. Okay, let's see. Another thing you would have learned in your pre-calculus course is that the graphs of f and f prime are symmetric about a line. They'll always be symmetric about the line y equals x. So again, let's take a look at our graph. Okay, so here's our function f of x. Here's our function f inverse of x. Here's the line y equals x, and I think you can see the symmetry in the line y equals x. Okay, so now let's talk about some calculus. All right, if f is, let's see, continuous, if f is continuous on its domain, then f inverse will also be continuous on its domain. Okay? Secondly, if f is differentiable, on an interval containing c, then sorry, and as long as, oops, sorry about that, as long as f prime of c does not equal 0, all right, then f inverse is differentiable at f of c. All right, we'll talk about graphically what that means in a second. And then let me just end with this formula. If we want to talk about the derivative of an inverse function, okay, derivative of an inverse function. Now you have to look real closely at this notation. Notice I have that f to the negative 1. That indicates the inverse. And then do you see this tiny apostrophe here? What we're talking about is f inverse prime of x. So that would be the derivative of f inverse. So here's how we can find the derivative of f inverse. We would take 1 over f prime of f inverse of x. So again, notice the notation. The apostrophe means a derivative. The negative 1 power means an inverse. Okay, so because of this crazy notation, it might be a better idea to define it a different way. So sometimes it's easier to define the derivative of the inverse of a function like this. Instead of using f to the negative 1 of x, let's use a different notation. Let's just call g of x the function that is the inverse of f of x. Well, if g of x is the function that's the inverse of f of x, then to find the derivative of that inverse function, we will just take 1 over f prime of g of x. Okay, you can see that this notation is a little bit less confusing than this notation. So we'll tend to use this notation a little bit more. Now, we have to add the point that f prime of g of x cannot be equal to 0. So let's take a look at an example. We're given this function f of x. Oh, and there's a typo in this. If you would change this, we're given this function f of x equals 1/4 x to the third plus x, and this is supposed to be a subtraction sign. So if you could change that to -1. Okay, so we have this function f of x, and then we're also told that g is the inverse of function f. Okay, so we're going to find two things. We're going to find g of 3 and then g prime of 3. So we're going to find the value of the inverse function at 3, and then we're going to find the value of the derivative of that inverse function at 3. So first of all, if you take a look at the graph, here we have f of x, and then here we have our inverse function g of x, and you see that symmetry in the line y equals x. Okay, one thing I want you to notice is that we're given a point on f of x. We're told that f of 2 is equal to 3. Well, if f of 2 is equal to 3, then that's going to help us know what g of 3 is. Because remember, the x's and the y's switch places. All right, so if f of 2, let's just make a note. How about right here? If f of 2 is equal to 3, okay, if f of 2 is equal to 3, then therefore g of 3, we can just turn that around and say g of 3 is equal to 2. So we have found g of 3, and now we're going to find out what g prime of 3 is. So to find g prime of 3, let's just use our formula that we're given a minute ago. G prime of 3 would be equal to 1 over f prime of g of 3. All right, so let's just figure out what f prime of g of 3 would be. Well, what is g of 3? Just a moment ago, we said that g of 3 was equal to 2, right? So this is the same thing as 1 over f prime of 2. And now we need to figure out what f prime of 2 is. Well, we were given a function for f of x. So let's go ahead and find the derivative of that function, and then we'll evaluate that function at 2. So if f of x equals 1/4 x to the third plus x minus 1, then that means f prime of x would be equal to, let's see, 3 times 1/4 would be 3/4 x to the second, and then plus the derivative of x is 1. All right, so that's our f prime of 2. Now we need to f prime of x. Now we need to evaluate that function at 2. So what would f prime of 2 be? Well, that would be 3/4 times 2 squared plus 1. 2 squared is 4, and 3/4 times 4 would be 3. So that gives us 3 plus 1, which equals 4. Okay, so now we can go ahead and finish finding g prime of 3. So it's 1 over f prime of 2. We have just evaluated f prime of 2 right here, and we've gotten 4. So this is equal to 1 over 4. Okay, so now let me simplify this a whole bunch for you by taking a look at this next question. The next question says, what is the relationship between the slope of f of x at 2, 3 and the slope of g of x at 3, 2? So let's go over here and take a look at the graph. Okay, notice that the slope of f of x at 2, 3, that slope is equal to 4. So I'm just going to try and sketch that tangent line. And I think it's reasonable that could look like a slope of 4. But if we look at the corresponding point on g of x, okay, at 2, 3, that slope, we just did the work, that slope is equal to 1/4. All right, and so what is the relationship between the slope of f at the point 2, 3 and the slope of its inverse g at the point 3, 2? Well, you can see that those two slopes are just reciprocals of each other. So that's going to simplify this process a whole bunch. So what is their relationship? They are reciprocals of each other. So how can we make this simpler? If we just remember that if we try to find the slope of the tangent of an inverse at a point, it's just going to be the reciprocal of the slope of the tangent of the original function at its corresponding point. Okay, so let's keep that in mind as we look at our next example. So the next example 2 says, let y equal the square root of 25 minus x squared. The first thing we're going to do is we're going to evaluate that function y at 3. So let's just go ahead and look at our function. Where we see an x, we're going to put in a 3. Okay, so that then y of 3 would be equal to the square root of 25 minus 3 squared. So that would be equal to the square root of 25 minus 9, which is 16. And the square root of 16 is 4. Okay, so that means when x is 3, in our original function, when x is 3, the y value is 4. Okay, the next thing we're going to do is we're going to find the derivative of y. Well, if y equals the square root of 25, if y equals the square root of 25 minus x squared, then to find the derivative, to find y prime, remember to find the, let me just write over here, that if f of x is equal to the square root of x, remember we practiced this the other day on a worksheet, then f prime of x is going to be 1 over 2 times the square root of x. So we're going to use that property, but in this case we're going to have to use the chain rule. Y prime would be 1 over 2 times the square root of 25 minus x squared. But then since this function, since we have a function underneath the radical, we're going to have to use the chain rule and take the derivative of the inside. The derivative of 25 minus x squared would be negative 2x, or negative 2x. Okay, and then we can simplify that a little bit. We can cancel these 2's. Oh, whoops, that's negative 2x. Okay, the derivative of 25 minus x squared is negative 2x. So we'll cancel the 2's, and so y prime simplifies to negative x over the square root of 25 minus x squared. And since in part C, we're going to be asked what is the derivative of the inverse of y evaluated at the point x equals y of 3, let's go ahead and go back to part B, and let's evaluate this function at x equals at x equals 3. Remember, previously we found y of 3. Y of 3 is equal to 4, so we want to know what the derivative of this function is at 3. So I'm going to evaluate my derivative at 3. So that would be negative 3 over the square root of 25 minus 3 squared, or negative 3 over 25 minus 3 squared is 25 minus 9, and 25 minus 9 is 16, and the square root of 16 is 4. Okay, so negative 3/4 is the slope of the original function at the point 3, 4. Okay, so now let's keep that in mind as we go to answer part C, where we're asked, what is the derivative of the inverse function of y evaluated at the point x equals y of 3? Well, remember what y of 3 was. Y of 3 is equal to 4. So in other words, what's the derivative of this inverse function when x is equal to 3? Okay? All right, well, excuse me, not x equals 3. It's x equals 4. Let me fix that. So x is equal to 4. Okay, so remember, the derivative of the inverse would be the slope of the tangent of the inverse at the point 4, 3. In fact, let me just write that down for you. So what are we looking for? If it says, what is the derivative of the inverse function of y evaluated at the point x equals y of 3, that's where x equals 4. What this is asking us to find, it's asking us to find the slope of the tangent line of the inverse at the point 4, 3. All right, so the slope of the tangent of the inverse at the point 4, 3 is going to be just the reciprocal of the slope of the original function at the point 3, 4, which we found earlier, which is right here. Okay, so all we need to do is take this slope, take its reciprocal, so flip it over. So this slope is going to be equal to negative 4/3. It's just the reciprocal. Okay, let's take a look at the next example. The next example says, let f of 4 equals 7, f prime of 4 equals 5/9. Then we're being asked to find what is g prime of 7. What is g prime of 7, which when g is the inverse of function f? Okay, so remember, g prime of 7, okay, the derivative of the inverse function is just going to be the reciprocal of the derivative of our function at 4, 7. So at 4, 7, the derivative of, or the slope of that tangent line is 5/9. Okay, so what is the derivative of g7? Remember, if f of 4 is equal to 7, that means that g of 7 is equal to 4. Remember, x's and y's just switch places. So what is the derivative of g prime of 7? Well, it would be the reciprocal of the derivative of f at the point 4, 7. Well, we're given that derivative is 5/9. So all we have to do is flip it over, and our answer then would be, let's see, choice E. It would be 9/5. So let's take a look at example number 4 that says, let h of x equal this function, x cubed plus 3x minus 1, and h of 1 equals 3. We're also told that the inverse of h of x is g of x, and we're asked to find g prime of 3. So in other words, we're going to find the derivative of the inverse function. Okay, so first of all, let's just make a note that if h of 1 is equal to 3, that means that g of 3 is equal to 1. So then to find g prime of 3, let's remember that g prime of 3 is equal to 1 over h prime of g of 3, all right, which would be equal to 1 over h prime of, remember that we said g of 3 is equal to 1, so h prime of 1. So now we need to evaluate h prime of 1. Well, to evaluate h prime of 1, we're going to have to go and find the derivative of h of x. So let's do that real quick. If h of x is x cubed plus 3x minus 1, then h prime of x would be equal to 3x squared plus 3, and then h prime of 1 would be equal to 3 times 1 squared plus 3, which is equal to, let's see, 3 plus 3, which is equal to 6. All right, so then that means this is equal to 1 over 6, and that's our answer, okay? And notice that h prime of 1, so at the point 1, 3, h prime of 1 is equal to 6. Notice that the derivative of the inverse at the point 3, 1 is the reciprocal. So now let's take a look at example 5 that says, using the table below, if h to the negative 1 is the inverse of a function h, write an equation for a line tangent to the graph of y equals h inverse of x at x equals 3. Okay, anytime you see these directions, write an equation for a line that's tangent. Start by writing point slope form. Which would be y minus y sub 1 equals the slope of m times x minus x sub 1. Okay, so now let's interpret what this table means here. We have x is 1, h of x is 3, and h prime of x equals 5. So let's just kind of write down, let's summarize what that means. What this table tells us is that the slope, it tells us that the slope of h at the point 1, 3 is 5. Remember, h prime of x is the slope of the function that gives you the slope of the tangent line, so h prime of 1 would be equal to 5. So the slope of h at 1, 3 is 5. Okay, so let's interpret what that means for the inverse function. What that means then is that let me write it up here, that the slope of h inverse at the point 3, 1 would be the reciprocal of this slope. The reciprocal 5 is 1/5. Okay, so now if we're going to write the equation of that tangent line at the point 3, 1, we'll just plug into our equation. We'll say then that y minus y sub 1, well, the y value of our point is 1. So y minus 1 is equal to the slope of that inverse at the point 3, 1, which is 1/5, and then times x minus x sub 1, which would be 3. All right, and then let's take a look at number 6. Number 6 says, given that f of g of x equals x, and f of 1 equals negative 5, f prime of 1 equals 2/7, what is g prime of negative 5? Well, first of all, let's talk about what this means. If f of g of x gives us x back again, what does that tell us about the functions f and g? Well, they must be inverses of each other. They just undo each other. If I start with a number x, and then I perform the function g on that number, and then turn around and perform f on that number, and I get x back again, that means that f and g are inverses of each other. Or another way we might want to say that is g is the inverse of f. Sorry about that. Okay, now, so to find g inverse of 5, g prime of 5. Okay, g prime of 5, remember, would be 1 over f prime of g of 5, okay, which would be equal to 1 over f prime of, well, remember, if f of 1 is negative 5, that means that its inverse, g of negative 5, is equal to 1. So g of 5, oops, I think I had, oops, I need to go back and put a negative right here. Sorry about that. So 1 over f prime of g of negative 5 means the 1 over f prime of 1, which is equal to 1 over 2/7. Remember, f prime of 1, we're told right here, is 2/7. So that's just a long way of saying my answer is 7/2. Remember that the slope of the inverse at the point negative 5, 1 is just going to be the reciprocal of the slope of the original function at the point 1, 5. So they're just reciprocals of each other. Okay, so now let's take a look at derivatives of inverse trig functions. Now, let's just quickly review what is an inverse trig function. Well, let's take a look at a trig function. For example, what is the sine of pi 6? Well, the sine of pi 6, hopefully you have that memorized, is equal to 1/2. Okay, so now let's talk about the inverse function, sine inverse. Sine inverse, if we take sine inverse and perform that function on 1/2, what that's going to do is that's going to give us the angle whose sine is 1/2. So if the sine of pi 6 is equal to 1/2, then sine inverse of 1/2 is equal to pi 6. All right, so that's what inverse trig functions do for us. They give us the angle that for any particular trig value. Now, I wrote it as sine to the negative 1. That's how I wrote sine inverse. But often in calculus, we don't use this notation. You'll often see this notation, arc sine. So if you've never seen arc sine before, all arc sine means is sine inverse. Okay, so here's the list of all 6 derivatives of inverse trig functions. Now, this looks a little overwhelming, but let me simplify this for you. First of all, the only two that you really need to know are these two. The derivative of arcsine and the derivative of arctangent. Those are the only two that you will probably be tested over on the AP exam. Although I will just point out that notice that the derivative of arc cosine is just the opposite of the derivative of arcsine, and the derivative of arc cotangent is just the opposite of the derivative of arctangent. But anyway, these are the only two that we really need to know. So let's just do a few examples. Let's start with this first example, letter A. Let's find the derivative of the arcsine of 2x. Okay, so looking at our formula, okay, the derivative of arcsine of u is going to be u prime over the square root of 1 minus u squared. Okay, so in our example here, u is equal to 2x. Okay, so this is a little bit of chain rule here. So to find the derivative of arcsine of 2x, let's first identify u as 2x, and then just use the formula. That's going to be equal, that's going to be equal to u prime. Well, if u is 2x, then u prime would be 2 over the square root of 1 minus u squared. Remember, u was 2x, so we're going to square that. And then we'll just simplify this just a little bit. Let's go ahead and square that 2x. So we'll write our final answer as 2 divided by the square root of 1 minus 4x squared. Okay, let's take a look at an arctan problem. So letter B says, find the derivative of arctan of 3x. Okay, so we'll use this formula. Arctan of u is equal to u prime over 1 plus u squared. No square root this time in the denominator. So in this example, u is equal to 3x. Okay, so u prime is equal to 3. So our derivative of arctan of 3x is just going to be u prime, which is 3, over 1 plus u squared. Remember, u was the function 3x. So we'll square that, and then let's just go ahead and simplify that a little bit and write it as 3 over 1 plus 9x squared. All right, so now let's take a look at the last one, the derivative of arcsine of the square root of x. Well, if u is equal to the square root of x, okay, then u prime, remember the derivative of the square root of x is 1 over 2 times the square root of x, all right? So now let's find the derivative of arc sine of square root of x. So using our formula, it's just u prime over the square root of the square root of u prime over the square root of 1 minus u squared. So u prime is 1 over, it's 1 over 2 times the square root of x, and then we're going to put all of that over the square root of 1 minus u squared. Remember, u was the square root of x, so we're going to square that. Okay, and then simplifying that just a little bit, we can bring this 2 square root of x and bring it down here in the denominator. So let's just go ahead and write our final answer as 1 over 2 times the square root of x, and then times the square root of 1 minus, now remember, the square root of x squared is x, so 1 over x. And we'll just leave our answer like that. All right, so now what you need to do is take a look at the worksheet, work as many as you can, be sure and make a note by the ones you have questions on, and then I'll be sure and help you next time we have class. So thank you for your attention, and good luck on the homework.